Hi guys, my name is Premasim Jain and today we will look for the quick sort. So what is the quick sort? Basically we have a test case here, test driven development. So you are trying to give an array and then you are expecting the array to get sorted something like this. So let's run this test case. Once we run it, this unsorted array gets sorted out over here. So this is pretty much it. Like this is what is the sorting thing, but how it is done behind the scene, what is happening. So this method, which is called as quick sort, is working behind the scene, and this method works in recursion, which means this method calls itself couple of times, which generates a tree. So how would that tree look like? I would show you with the help of images. So something like this, that once you give it an array and then it is in next pass it creates it call itself, and then it further calls itself, and then it generates a kind of tree. The best example image would be, let us try to find out something like here. Yep. So this is creating, and then once the recursion gets completed it would start traveling upwards. So let's see what's going on here. So it is calling these two methods, but before that the important thing for any recursion is the closure, like when it gets closed. Otherwise it would go infinite loop, it would go out of memory, because each execution is not only calling itself but also double of the time. So it is expanding like a chain reaction. So this is the point where it would stop, because we are incrementing the start, and as long as start is less than end, this would be good. And after certain point, when the start is incremented, this will no longer call itself and the recursion will get stopped. So a quick sort is also called as the partition sort. So the primary thing is the partition or the pivot point. So to understand, we have a number, and whatever are the number before that we would compare with it and then swap it. For example, 30 is less than 70, but 80 is not. So we will swap 30 and 80. So this is how it happens. Let me explain you here. So we are taking the pivot number, which is usually the end, but even if you take any number, maybe start or any other number, it would still work. So we are taking we are following the AND way, by the way, right? So then we are taking a number which is j, which is apparently less than what we start, and then we will swap it as it goes. So we will compare each time this number is less than this. If it is so, then we have to swap it with the other bigger number. For example, this is 30 and 30 is less than 70. So what we are going to do, it would remain here. With 80 is less than 70, no. So 40 is less than 80, so we will swap 40 and 80. And final stage would be the 70 would come somewhere in between, and then we would have a guarantee that all the numbers on the left side of the pivot point are smaller than the pivot number, and all on the right are greater than the pivot number, and that's how we get the sorting done. This would be our final stage. So I hope you like it. I know it's a little bit complex, so you can try out this code from my GitHub link, and then read this article on the Geeks for Geeks. This is like really cool, and it explains the concepts really nice. You can also take help of Wiki for the quick sort. Thanks guys, thanks for watching.